In this video, I will be explaining about logarithms, and let's begin. So first of all, what is logarithms? A logarithm is an inverse, fx means function, inverse function of an exponential function. So let's begin with exploring what exponential function is. So here we see three different equations and graphs. The first one is a linear equation, and the second one is a quadratic equation, which all of you are familiar with already. So then what is this third equation? It doesn't look like a quadratic nor a linear. As you may have guessed, it is an exponential function. So an exponential function is a function with a constant base and a variable power. So where a base is a and the function and the power is x. So for example, y equals 2 powered by x would be an exponential function. Be careful with being confused with y equals x squared. In this case, it's a quadratic function. It's an exponential function, and the base is the variable, and the power is the constant. So that's the difference between the quadratic function and the exponential function. So in an exponential function, there is an exponential growth curve and there's an exponential decay curve. The difference is that in an exponential growth curve, as the value of x is increasing, the total function value is increasing as well. So here the y value is increasing as x is increasing. Exponential decay is the vice versa. As the x value is increasing, the y value is getting smaller. And notice how here the curve does not go below 0. Of course, this is just a made-up graph, so it may not seem that clear to you. So let's look at this table here. When x is 0, 2 powered by 0 is 1. Any exponential function with a power of 0 would be 1. I'll be explaining this further later on, but for now, let's just keep it like that. Here we have the equation y equals 2 powered by x. Let's put 2 in. 2 powered by 2 is 4. 2 powered by 4 would be 16. What if x is a negative value? 2 powered by negative 2 would be 1 over 4 because the function, then the 2 powered by x goes to the denominator side. That's what happens when x is a negative value. So it will be technically 1 over 2 powered by 2 when you have a function 2 powered by negative 2. So what if x is a negative 4? Then 2 powered by negative 4 would be 1 over 2 powered by 4, which is 1 over 16. What if x is fraction? Still works the same. It's just 2 powered by 1 over 2, which is radical 2. In all cases, it doesn't go below 0. This concept that is known as an asymptote. An asymptote is a line that endlessly approaches but never meets. So in here, let's assume that this graph is a graph of 2 powered by x. As it is increasing, there is no limit in the x-axis, but in the y-axis, this function can never meet the 0. In this case, this line over here, it can never go below that. Of course, this changes by situation. As I've told you before, if the graph is like 2 powered by x minus 5, then it will be assumed that the function can never be a smaller value than a negative 5. Because this varies by situation, and we'll be going into asymptote in a further depth later on. So then, what is an inverse function? Let's go slowly. So let's say we have this quadratic function here. What would happen if we flip this horizontally? If we flip this through the y-axis, it would become like that. The red graph is now the flipped version by the y-axis. What if we flip this function by x-axis? Then it will look something like this. An inverse function is basically doing both of those. It's flipping it vertically and horizontally. Of course, in a test, if it asks you the definition, you can't really explain it like that, but that's literally the concept. And if you do that, it's literally the same as flipping it through this diagonal line here. If this is kind of if you find this way hard to understand, then another way that's really simple to understand this is it's just basically changing x and y. So remember, we had a function. We said that how exponential function is of shape like this: y equals a powered by x. Literally, what an inverse version would look like is x equals a powered by y. The reason why I explained to you the horizontal and the vertical, this diagonal line first, is because in a test it often asks you to uh, draw the inverse function. And when you do that, if you think it like this, flipping it through the diagonal way is going to really be helpful when you are drawing the inverse function of a given function in a problem. So remember in the beginning we have asked what is logarithms? Logarithm is an inverse function of an exponential function, and we have just gone through what types of exponential functions are, what it is, and we have gone through what inverse function is. And it's the combination of those both that leads to the concept of logarithms. The logarithm equation generally looks like y equals log base a x, and we will continue to explore this concept in future videos. Thank you for watching and hope you liked it.